Om Shri Sai Ram. Nature, there are many carbon and its compounds are present. Or in our daily life, we are using many carbon and carbon compounds. Why? What is the reason? In nature, there are most of the materials or most of the substances which are made up of carbon, or they are compounds of carbon. What is the reason? Because versatile nature of carbon. What is the reason? Versatile nature of the carbon. In that, you have studied in the last class, that is covalent bond. Carbon bonds with another carbon atom, or carbon which bonds with another some of the elements with the help of covalent bond. Now another one is catenation. Why carbon and its compounds are more number of carbon and carbon compounds are present in nature? Because catenation. This is a very important concept, catenation. What do you mean by catenation? I will show one example. Carbon, another carbon, one is a carbon atom, another carbon atom, another carbon atom. There are 4 carbon atoms. For example, how many carbon atoms are present in this example? 1, 2, 3, 4. Now, every carbon, it contains 4 electrons in its outermost shell. It means here it is a 1 electron. It bonds with, this valence electron bonds with another carbon atom. This one bonds with another carbon atom. This electron, the valence electron of this carbon, which bonds with the valence electron of this carbon, and these are called single bond. This bond is formed because of covalent bond. Why this bond is formed? Because of covalent bond. Now this is called catenation. Now tell me, what do you mean by catenation? Why it is called catenation? Catenation means the special ability of carbon. This is the special ability of carbon, or carbon has the unique ability to form bonds with other atoms of carbon. Just look at this. Carbon bonds with carbon, another carbon atom. This carbon bonds with another carbon atom through covalent bond. That is called catenation. If I write like this, carbon bonds with hydrogen is example for catenation. It is also a covalent bond, but it is not catenation. What is the condition for catenation? Catenation means carbon bonds with carbon through covalent bond to form a chain. Then it is called catenation. Very simple. Carbon bonds with another carbon atom through covalent bond. Which bond? Through covalent bond. Form a chain. Not only chain. If it is formed a ring structure, then also it is called catenation. This is also example of catenation. If I write like this. Now carbon atom bonds with another carbon atom through covalent bond, and it forms a ring. Or closed structure. Then it is also a catenation. So what do you mean by catenation? Catenation is the binding of an element to itself through covalent bonds to form chain or ring molecules is called catenation. There are 3 types of catenations. It is not given in the textbook. There are 3 types of catenation. One is straight chain. This is straight chain. Why? Carbon bonds with covalent bond. Carbon bonds through covalent bond and form a chain. So it is a straight chain, therefore it is straight chain. I will write another example. This is also a catenation. There is any difference between these two? There is any difference between this one and this one? Yes, there is a difference. This is a straight chain. It is also a catenation, but this is straight, then there is a branch. So it is called branched chain catenation. This is called branched chain catenation. And third type is closed chain or closed structure, or it is also called ring structure. Why ring? Because it is closed. It is a ring. So there are 3 types of catenation: straight chain and branched chain. This is branched chain. Example for branched catenation: and this one is closed, or another name for this one is ring structure. So these are the three types of catenation. These are example for catenation. Another example, just look at this. Carbon bonds through covalent bond form a chain. How many valence electrons are present in carbon? You know that it is 4. Now one is bonded with valence electron of another carbon. How many electrons are now present in for this carbon, first carbon? 1, 2, 3 and 4. Now this bonds with any other atoms like hydrogen, nitrogen. It can be shares electron with hydrogen, or it is oxygen and nitrogen, and it forms different compounds. Why? If it is a carbon, it bonds with 4 hydrogen and it becomes methane. It becomes methane. Methane is a hydrocarbon. So there are number of different compounds formed because of the valence electron. It contains 4 valence electron. If one valence electron which shares electron with valence electron of another carbon, then rest of the valence electron which may share with any other elements, for example oxygen, nitrogen or hydrogen, and it forms a different compounds, because carbon hydrogen, it becomes compound because there is no single element. More than one element means it's a compound. If it shares nitrogen, and it becomes a compound of nitrogen and carbon. If shares with oxygen, and it becomes compound of hydrogen, it's a compound of oxygen and carbon. So there are many carbon and its compounds are present in the nature. This is the reason. That is the versatile nature of carbon. One is catenation. What do you mean by catenation? The carbon has the unique ability to form bonds with carbon atoms through covalent bond. It is called catenation. This is the versatile nature of carbon. Next topic is hydrocarbon. Hydrocarbon. The name suggests hydrocarbon. Yes, tell me, what do you mean by hydrocarbon? It is also a compound of carbon because it contains carbon. Not only carbon, it is not element. Hydrocarbon, it is a compound of hydrogen and carbon. So it is called hydrocarbon. Very simple. What is the definition for hydrocarbon? Hydrocarbon is a compound. Why it is a compound? Because it is a compound of hydrogen. Hydro means hydrogen and carbon. Therefore it is called hydrocarbon. Now hydrocarbon is classified into 2 types. This is a very important flow chart. Just write down this flow chart because it is not given in the textbook, but it is very important. It is the basic thing for hydrocarbons. Hydrocarbons are classified into 2 types. One is acyclic and second type is cyclic. There are 2 branches in hydrocarbon. It is classified into 2 types, acyclic and cyclic. And in acyclic there are 2 types. Once again, this acyclic is classified into 2 types. One is saturated and second one is unsaturated. Saturated and unsaturated. Then this saturated is further classified into only one type, that is alkane. It is alkane. Then unsaturated is classified into alkene and alkyne. So come to the point. Hydrocarbon is classified into 2 types, acyclic and cyclic. In acyclic there are 2 types, saturated, unsaturated. In saturated only type, that is alkene. In unsaturated there are 2 types, alkene and alkyne. Now cyclic is classified into 2 types. It is alicyclic and aromatic. The second type is aromatic. Then it is also further classified into different forms, but it is not required for 10th class. Now you have to remember this one, hydrocarbon and its classification. Just write down this flow chart. It is not given in the textbook. It is very important. Otherwise we cannot understand what is the different types. Now come to the point. Hydrocarbon means acyclic and cyclic. Acyclic means the carbon in this catenation. Which type of catenation is acyclic means? It is a straight chain or branched chain. It may not be a ring structure. The name suggests acyclic. It is not cyclic. Cyclic means this is cyclic. It is a closed, so it is the cyclic. It is cyclic. Why it is cyclic? Because it is closed chain. So acyclic means it does not have an closed structure, therefore it is called acyclic. So it contains straight chain or branch chain. Saturated and unsaturated, these are the two types. Why it is called saturated? Saturated means the carbon atoms having single bond between them, then it is called saturated. What is the saturated means? In between the carbon atoms there is a single bond. I will write down an example. Just look at this. This is a carbon, this is another carbon, this is another carbon. In between the carbon there are single bond. Carbon atoms having single bond between them, they are called saturated. They are called saturated. So this is saturated. Now second classification is unsaturated. Why it is called unsaturated? Unsaturated means the in between the carbon atoms there is a double bond or triple bond. So two carbon atoms or carbon atoms having double bond or triple bond, then it is called unsaturated. Or carbon atoms having triple bond means it is a unsaturated. So very simple, what do you mean by unsaturated? Carbon atoms having double bond or triple bond, then it is called unsaturated hydrocarbons. Next, saturated is further classified into only one type, alkane. What is the definition of alkane? Alkane means carbon atoms having single bond between them. Same definition, saturated. What is alkane? Alkane means the carbon atoms having single bond between them, they are called alkane. Now alkene. Alkene means carbon atoms having double bond between them, they are called alkene. Because unsaturated means carbon atom having double or triple bond, then it is unsaturated. But alkene means in between the carbon atoms there is a double bond. Then alkyne means in between the carbon atoms there is a triple bond, then it is called alkyne. So very simple, alkane means in between the carbon atoms single bond, alkene means in between the carbon atoms is double bond, in alkyne means in between the carbon atoms it is triple bond. So these are the classification. We will see alicyclic and aromatic further. If we list the different hydrocarbons, methane, ethane, butane, pentane, hexane, methane, ethene, hexene, butene, then methane, ethane, there are many hydrocarbons are present. You have to write the molecular formula and structural formula for different hydrocarbons. Can we by heart for this? Then we get the molecular formula and structural formula. It is not possible. There is a simple idea to writing a molecular formula or structural formula. The simple method. What is the method? Just look at the boards. If methane, if carbon atom is 1 means it is meth. Just remember, if any hydrocarbon which contains carbon atoms is 1 means it is meth. If carbon atom is 2 means it is eth. If carbon atom is 3 means it is prop. Just write down this. If carbon atom, hydrocarbon means it is a compound of hydrogen and carbon. If carbon atom is 1 means you have to remember it is meth. If carbon atom is 2 means it is eth. If carbon atom is 3 means it is prop. Then carbon atom is 4 means it is but. Carbon atom is 5 means it is pent. If carbon atom 6 means it is hex. It is 7 means hept. 8 means oct. 9 means nan or nano. Some textbook it is given as penta, hexa, hepta, octa, nano or nan. Then 10 means dec. Just remember these points. If carbon atom is 1 means it is meth, 2 means eth, prop, but, pent, hexa, hepta, octa, nano, deca. These are the, if carbon atom is 1, 2, 3, 4, 5, 6, 7, 8, 10. Then another one, alkane, general molecular formula for alkane is CnH2n plus 2. Just remember this one. General molecular formula for alkane is CnH2n plus 2. For alkene it is CnH2n itself. So alkene is CnH2n. Then alkyne means CnH2n minus 2. Now, general molecular formula for alkane is CnH2n plus 2, alkene is CnH2n, then alkyne is CnH2n minus 2. These are the general molecular formula. And also we know that alkane means in between the carbon atom there is a single bond. So, single bond, alkane, you have to remember it is a single bond. Then alkene means in between the carbon atom there is a double bond. So alkene means double bond. This is double bond. Then alkyne means in between the carbon atom there is a triple bond. So it is triple bond. If you remember these things, then you should write different acyclic hydrocarbons structural formula and molecular formula very easily with. If you remember these points, then you should write different acyclic hydrocarbon structural formula and molecular formula with the help of these. If carbon atom is 1 means it is a meth, eth, prop, but, pent, hexa, and general molecule of alkene is CnH2n plus 2, alkene is CnH2n, alkyne is CnH2n minus 2. Alkane means single bond, alkene means double bond, alkyne means triple bond. From this we can write the molecular and structural formula of acyclic hydrocarbon. For example, write the molecular and structural formula of ethane. Just remember what is ethane. Please write down this in your notes. It is also not given in the textbook. Just write down these points. Now write down this question. Write the molecular formula and structural formula of the following. What is the question? Write down in your notes. Write the molecular and structural formula of the following. First hydrocarbon is ethane. It sounds ethane. E-T-H-A-N-E, ethane. If we classify this, ethane, which belongs to, now tell me, ethane belongs to alkane, alkene or alkyne. First, it belongs to, tell me, it is alkane or alkene or alkyne? Yes, it is a alkane. Why it is alkane? Look at the suffix, ane. It ends with ane. The suffix is ane. So, alkane means its suffix also ane. So, alkane, just look at the sounds. Alkane, ethane, methane, butane, hexane, pentane. It ends with ane means it is always alkane. Now we know that ethane is a member of alkane. Ethane is a member of alkane. So write down the general molecular formula. What is the general molecular formula? CnH2n plus 2. Got the idea? Ethane means it is a alkane. Why it is alkane? Because ane. If it is given ethene, then it is alkene. If it is given ethine, then it is alkyne. Now it is ethane, so it is a alkane. So it is a alkane. What is the general molecular formula of alkane? Write down the general molecular formula. CnH2n plus 2 is a general molecular formula of alkane. Now, eth means how many carbon atoms? If carbon atom is 2 means it is eth. If carbon atom is 3 means it is prop. If carbon atom is 7 means it is hept. Ethane means how many carbon atoms? Eth means if carbon atom is 2 means it is eth. Now n equal to 2. If they given propane, it starts with the prop. If carbon atom is 3 then it is prop. Now it is ethane. It starts with eth. What is the carbon atom? If carbon atom is 2 means it is eth. So n equal to 2. Write down n equal to 2. Now substitute the value of n. Cn. Instead of write n, what is the value of n? N equal to 2. So C2. Then H. 2 into n. 2n means 2 into n. What is the value of n? N is 2. So 2 into 2. After that 2n plus 2. So plus 2. Now substitute. What we get? C2. 2 into 2, 4. 4 plus 2 is 6. So C2H6 is the molecular formula of ethane. Can we by heart this? To find the molecular formula of ethane? No need of this, because from this general molecular formula, and if carbon atom is 1 then it is eth prop. From that we can write the molecular formula of any acyclic hydrocarbon. This is the method. This is the molecular formula. C2H6 is a molecular formula of ethane. Now write down the structural formula. It is very simple. C2H6. How many carbon atoms are present? C2 means carbon is 2. Carbon 1, 2. C2 means carbon 2. Then ethane means ane. The ends with the suffix ane. Ane means it is a alkane. What is the bond in between the alkane? This is single bond. So carbon atoms having single bond between them. If it is a ethene, it is a alkene. What is the bond present between the carbon? It is double bond. If it is a ethyne, then what is the bond between carbon atoms? That is triple bond. Now it is ethane. So single bond between the carbon atom. Now single bond. We know that. What is the valence electron present in carbon? What are the, how many numbers of electron present in the outermost shell of carbon? It is 4. Now one electron, it bonds with valence electron of another carbon. So one carbon, one electron. Now 3 electrons are left. This dot refers electrons. For this electron, one is bonds with the another carbon, and another 1, 2, 3. This bonds with, just put a line. This bonds with hydrogen. Just write down hydrogen. It is hydrogen because it is hydrocarbon. It is a compound of hydrogen and carbon. So it bonds with hydrogen, hydrogen, hydrogen and hydrogen. Now count. How many C? 1, 2. So C2. Just count the hydrogen. 1, 2, 3, 4, 5, 6. Yes, C2H6. It is a structural formula of ethane. Now write down another one. Write down in your notebook propane. Write the molecular formula and structural formula of propane. Propane belongs to alkane, alkene or alkyne. Just tell me. Propane belongs to alkane or alkene or alkyne. It is a member of alkane. Why alkane? The suffix is ane. Alkane means ane, ends with the ane. So it is alkane. It sounds alkane. Propane. If they given propine, and it belongs to alkyne. If it is given as propene, and it belongs to alkene. Now it is propane. What is the general molecular formula of alkene? Is it alkene? No, it is alkane because it is propane. What is the general molecular formula of alkane? Alkane is CnH2n plus 2. Now tell me, prop means how many carbon atoms are present in propane? From this, carbon atom is 3 means it is prop. So N equal to 3. N equal to 3. Now substitute the values. Carbon. N means it is 3. H 2 into N. The value of N is 3. So 2 into 3 plus 2. So C3. H 2 into 3. 2 3 is a 6. 6 plus 2 8. So C3H8 is the molecular formula of propane. What is the molecular formula of propane? C3H8. Then write the structural formula. How many carbon atoms are present? 3. So 1, 2, 3. It is a alkane. So single bond between. Carbon atoms having single bond between them. So single bond. So one carbon, one line is over, second, third, fourth. For this, 1 is over, 2 is over, 3, 4. 1, 2, 3, 4. Just 4 lines for one carbon. It is a simple method. How many lines for one carbon? 4 lines. That is 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. This lines refers covalent bond. It is not line, it is actually covalent bond. So 1, 2, 3, 4. Just write down 4 lines for each carbon. Write down for each line hydrogen. Just write hydrogen. Hydrogen. Now count the carbon. 1, 2, 3. Yes, C3. Count down the hydrogen. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. So this is the structural formula for propane. So there are many hydrocarbons are present. Now we have studied in this class different hydrocarbons, in that alkene, alkene and alkyne. What is the method of writing a molecular formula and structural formula? We have written some of the examples. What is the method to writing a molecular and structural formula? In the next class we will study and we will write many different hydrocarbons like alkene and alkyne. Sai Ram.